Yeah. So we are looking at the topic of measures of frequency and association. And usually, when we are covering this topic, we begin with the definition of epidemiology and look at the tools of measurement and the measures of frequency, morbidity, mortality, association. And we are just going to really go very quickly through some key concepts in these measures. So when we look at the measures of frequency, just 1 minute. Yeah. So when we are looking at the measures of frequency, um, we usually use such diagrams to understand the concept. So I'm looking at two villages, and the dotted lines are people who are healthy, and the solid lines are the ones where people are suffering from a chronic disease. So when we look at such a picture, so you have two villages, say the population of the two villages is similar to each other. And in one village, you find lesser number of cases, and in another village, you find more number of cases when you do a survey. What is your inference of these findings? Yes, anyone? We are doing a survey in two villages, village A and B, and both of them are having roughly, say, the same population. But when you do the survey, you find that, say, out of 2000, there are only 100 individuals suffering from the disease. In another village, there are 500 individuals suffering from the disease. So, what is your inference?
The
Anyone?
burden is more in the village which is having more numbers.
Great. Yeah, very good, Siva. So when we are doing this, actually what we are looking at in the this cross-sectional lens is we can say is that in this village the burden of the disease is more compared to this particular village. So if we look at the complete picture, might be that there were more cases in village A, because when you look at the previous picture, we feel that the burden is more in village B than A. But if we look at the complete picture, what possibly could be the truth is that there were more cases in village A compared to village B, or similar number of cases, but either those individuals recovered or they died before you conducted the survey. Now here they have died before the point of the survey, so the burden is less, right? So the word burden is very important here, and whenever you do a cross-sectional study, you can estimate the prevalence, and the prevalence, all the prevalence tells you is the burden of the disease. This is one key point to remember. And we all know how to calculate the prevalence, right? The number of cases divided by the total number of persons who are there with or without a particular factor. That is the prevalence of the disease in the exposed, and the number of cases amongst those who do not have the exposure, that is the denominator, that is the prevalence in the unexposed. And you can calculate then the prevalence ratio also in cross-sectional studies. So one estimate which you can calculate in cross-sectional studies is prevalence ratios. Now, sometimes what you are really interested is not burden. You are interested in is really the risk of the disease. So what is risk? Risk is very different from the burden. So the risk is actually a probability that a healthy individual will transit from a non-disease state to a diseased state. So it is a probability that the disease will occur in the population you are studying over a specified period of time. So in a specific population over a specified period of time, what is the probability that the disease will occur? That is risk. So the key, the sentence to remember in risk is that there is a transition from a non-disease to a disease state, and that is the risk which you want to estimate. So what is the chance of this transition happening? And your incidence is a direct measure of the risk. So when you are looking at the incidence, you are actually there is a need to do a follow-up of individuals who are free from the disease, and you watch them transitioning from a non-disease state to a diseased state. And so what you are assessing is risk. So are you understanding this?
Yes, ma'am.
Yeah.
Yes,
So
ma'am.
please remember that when you do a cross section, it's the burden or the prevalence which is there can, it can depend upon the risk per se. More is the risk, more can be the prevalence, but it also depends upon the duration which can be affected by cure or by death or by other alternative outcomes. So when you purely are interested in risk and risk factors, identifying risk factors, if that is the objective of your study, then it is important that you estimate the incidence and you actually witness the transition of individuals from a non-disease state to a disease state. And as we can think, this you are only confident when you do a follow-up of individuals. So this is possible in a cohort study or in an intervention study. That is measurement of the risk directly by calculating or estimating the incidence. So this is something which you need to remember. Now, when you are trying to look at doing a follow-up, there are two kinds of populations you can encounter. One is known as a closed population and the other is known as an open population. Now, what does this closed population mean? Closed population means that all individuals in your cohort are going to enter at the same point in time, and nearly all, or at least a majority of them, are going to complete the follow-up for the entire duration of the study. The outcome is usually rare, and there are alternative outcomes like dropout, or if your outcome is not death, death could be an alternative outcome. Those are also very, very rare. So majority of those who are there are entering and exiting your study at the same point in time. That is known as a closed population. Vis-a-vis the open population, in which there is left or right censoring, means people are entering the study at different points in time and they are exiting the study at different points in time because of various reasons. And the difference between the two is that in the closed population, maximum individuals are going to contribute equal duration of follow-up, while in the open population, individuals are entering and exiting at different times, so they are contributing different periods or duration of follow-up. So are you understanding this difference in the concept of a closed population and an open population?
Yes,
Yes,
ma'am.
ma'am.
So when you are confident that you have a closed or near closed population, what you calculate is known as a cumulative incidence, which is a probability or it is a proportion. So you have the total population who are there in the cohort is the denominator and the number of cases is the numerator. So that is known as cumulative incidence. But when you have an open population, your denominator is person time. So it can be person hours, person days, person months or years. So person, because each individual is contributing different period of follow-up, your denominator is person time. And the numerators is the same. That is the number of new cases which have occurred. That is the number of persons who have transitioned from no outcome to outcome in your follow-up. And what you calculate by doing this is known as incidence density. So when you talk of incidence rates or incidence, there are two kinds of measures you can come up with depending upon your population. If you are confident that your population is a closed population, you will calculate cumulative incidence, which is merely a proportion. And if you feel that your population is a open population, then you will have to calculate person years and then estimate incidence density. This is a pure rate. So whenever you have person time in your denominator, that is the only time that you can say that your measure is a rate. So just to summarize, the measures of the disease frequency are also closely linked to the study design. So prevalence is nothing but a proportion. It tells us the burden of the disease in the community and you get it with a cross-sectional study. While incidence, be it risk or rate, is occurrence of new cases, and you can calculate it only with a follow-up that is in a cohort or an intervention study. Incidence is of two types: cumulative incidence, which is a measure of the risk, where the follow-up period is the same for all participants in your study and there is low attrition. Rate, on the other hand, is known as incidence density, and here the participants have different lengths of follow-up, so you have person time in the denominator. So these are the different concepts which you need to understand. So you all know this so quickly. The numerators and denominators for cumulative incidence, you have the cases divided by the total number of individuals who have been exposed and non-exposed for the incidence in non. So the new cases which are occurring in those who are exposed, not exposed, that is your cumulative incidence, and you calculate when you divide one by the other, you are going to get the risk ratio. And if you are going to look at rate, then the new cases are in the numerator and the person time contributed by individuals who are exposed or not exposed comes in the denominator, and you calculate a rate ratio. So with cumulative incidence, you get a risk ratio, and with the incidence density, you get the rate ratio. Now, when you look at this particular picture, you will see that this is an open cohort, right? So all individuals may be entering the study at the same time, but there are different periods of follow-up. People are exiting at different points in time. Now, in both these scenarios, the participants are contributing 9 years of follow-up, total 9. So the lines which I have drawn, they are all contributing to 1 year. So each of this here is 1 year. So this is 1 year, this is 1 year, 1 year. And if you do the total, in both cases, it is 9 years. And in both cases, what you see is that there are two cases which have occurred. So the incidence rate will be 2 per 9 person years, or 22 cases per 100 person years. Are you getting me here?
Diagram, it is 2 cases.
Yeah, so the dots are the cases. These dots which are there, these are the cases. So there are 2 cases in both scenarios. And if you count 1, 2, 3, 4, 5, 6, 7, and 8 and 9. So 9 person years. So there are 4 people, but they are contributing to 9 person years in these 3 years of follow-up. While here again, there are 2 cases in the numerator: 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 5 individuals are contributing 9 person years of follow-up, and you have 2 in the numerator. Are you getting me here?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
What about others?
No, ma'am, I didn't get it, ma'am. That second
No,
diagram is
ma'am.
Yeah, I'll tell you all. See, this is the start of the cohort and this is the end of the cohort. And this is 1 year of follow-up. This is the second year of follow-up, and this is the third year of follow-up, right? So the first person is contributing 3 years of follow-up, right? This is 1 year, second year, third year. This person is contributing 1 year of follow-up. The third person is also contributing 3 years of follow-up. And the fourth person is contributing 2 years of follow-up. So total of 9 years of follow-up in this scenario. On the right hand side, the first person is contributing 3, the second 2, third 2, and these are contributing half years of follow-up. So total, you have 9 years of follow-up. Are you getting me here?
Oh, yes, ma'am.
Yeah. And then you have 2 in the numerator, which can be, estimated as 22 cases per 100 person years. Now, this is incidence density because you have person years in the denominator, and this is actually the average person time incidence rate. So the incidence density is the average incidence which is occurring in the period of follow-up. And the assumption you are making when you're doing or when you're calculating incidence density is that the rate of occurrence of these cases is constant throughout the study. Now, do you agree, looking at the 2 scenarios, that the rate of occurrence is the same in the period of follow-up?
Yes, ma'am.
Actually, if you see very closely, supposing we say these are cases or these are deaths, do you see any difference at the time? There is 3 years of follow-up, but the
Yes,
time,
ma'am.
yeah. So what is it that you are seeing?
Because in the second diagram, we can see that in the 1, 2, 3, the incidence is followed up in the first 1/4 time only, whereas in the first diagram,
Yeah,
uh,
yeah, you're right. So what you see is that these cases are occurring later on. The
I
period
see.
of follow-up is the same, but these cases are occurring late in follow-up, while these cases are occurring early on in follow-up, right? So this assumption that the occurrence or the rate is the same throughout the study period does not hold true. So when the rate is not constant, when you feel that your rate is not constant in the period of follow-up, it is not comparable, then what you calculate is known as this hazard rate, which is nothing but instantaneous incidence rate. So I will tell you what hazard rate is, but you have to understand that the drawback. So we saw what is prevalence, what is the drawback of prevalence, that it only tells us about the burden, not about the risk. If we want to study the risk, we will estimate the incidence. But the issue with incidence is it's telling us the average scenario with the assumption that whatever is happening is constant throughout your period of follow-up. But this assumption may not hold true because in some cases or in some communities, the outcome may be occurring early on, and in some communities, it may be occurring late in the follow-up, and this is not captured by your incidence density. When you suspect this is happening, you will have to calculate instantaneous incidence rate, that is known as hazard rate. And we will now look at what exactly is hazard rate. Now, this hazard rate is also in books mentioned as force of morbidity or mortality. And this word crops up when you are doing time to event analysis. So this what you're looking at is risk of the event occurring in small intervals of time in your follow-up. So in the follow-up period, you split it up into small intervals of time, and you calculate, the the risk of the event happening in those small intervals of time. So if you look at the formula, you will see that in the numerator you have incident cases which are observed in that small interval of time. So you have, say, t at the beginning, and the next minute could be your small interval of time. So how many cases have occurred in that 1 minute are your incident cases. And the denominator is all the number of persons who are free of the outcome at the beginning of that particular minute, and who have who in whom the outcome can occur at the beginning of that small time period. So what you do is you have a long period of follow-up, you split it up into small intervals, and in each interval of time, you find out the risk of the event occurring. That is known as the hazard. Are you understanding this concept?
Yes, ma'am. Ma'am, what about hazard rate in means like we can get in like small events like ICU settings or what?
Yeah, in any setting, wherever you have a follow-up, the thing is, if you suspect that you cannot average off the event happening, the period of follow-up, so you're following up someone for, say, up to the time of discharge after admission in the ICU. So instead of looking at all the entire period in one go, you are going to split it up into small, it could be, say, hours, and in each hour, how many of the deaths are occurring. So if
Yes,
there are
ma'am.
in two ICUs, if you look at the incidence or the mortality, it can be the overall, it may appear to be the same, but might be you suspect that in one ICU, the deaths are occurring early on compared to the other, then you can split that follow-up time into small units, and you calculate the risk of the outcome in each of those small units, and then you compare the two.
Yes, ma'am. Got
Yeah,
it, ma'am.
yeah. So this is also known as conditional instantaneous risk or conditional instantaneous probability. Conditional, the only condition is that at the beginning of that small interval of time, all the individuals who are in your denominator are free of the outcome. It is instantaneous because you're looking at the risk in that instant of time. So it is a conditional risk of failure. Failure is risk of occurrence of the outcome in extremely small intervals of time in which you have divided the entire period of follow-up. So the earlier slide where we saw the limitation, where we were worried about when is the event happening. That is, whenever the word time to event comes, that is the time, or when many of you are interested in survival analysis, that is the time where this hazard or hazard rate comes into picture, where you are dividing your follow-up time into small intervals, and in each interval you are assessing the risk of the event. Actually, it's the rate at which the event is happening in that small interval of time. So I will give you a simple example which will really bring more clarity. Now this, I have simplified it very much. So I want you to understand that this is just for the sake of understanding these concepts, right? So when you go on to understand higher concepts, and then if you look at this particular example, things may become complicated. But just till now what we have discussed, just to understand this, and when you are trying to explain to someone or to your undergraduate class, might be this can help. So you have two tanks, right? And water is filling the tank, and you want to see that on a particular day at a particular time, whether the water is more in one tank or the other. So you go and measure the amount of water which is there in both tanks. So this is prevalence, right? So you're going in one point in time and taking your data and measuring the frequency. That is your prevalence. Now, if you want to find out the amount of water which the two tanks get in 24 hours. So there is one mechanism you can do is at the beginning of the day, you go and measure the water in both the water level in both these tanks, given that all other measurements are the same for the tanks. And then at the end of the day, you again go and you measure the amount of water in both the tanks. And then you would know that which of these tanks has got more water in that 24-hour period. This is cumulative incidence. Are you getting me?
Yes, ma'am.
Yes, ma'am.
So this is so whatever water is there in the tank, that is the like a burden, it is already there. But the fresh water which has come in the 24-hour period, that is your cumulative incidence. Here, of course, you have to assume that there is no extra water coming from any other source, and there are no leakages and no different kinds of evaporation and loss of water in any form happening in the two tanks. But if this assumption does not hold true, that there are leakages and they are different in the two tanks, no one knows what amount of leakage is there by evaporation or by other means, then the cumulative incidence is not going to give you your answer about the amount of fresh water entering the tank in the 24-hour period. So what you can do is you can place a sensor. Now you will have to then shift from your tank to the tap, the flowing water from the tap. So you put a sensor at the tap water, and you calculate using the sensor the total amount of water which has been captured by the sensor in the 24-hour period. That is incidence density. The assumption you are making here is that the rate at which the water is flowing is constant, and then you are in the 24-hour period, the total amount of water which has crossed your sensor, that amount you can divide by say 24, and you get hourly amount of water which is entering the tank in both these taps. This is an example of incidence density. Are you getting me here?
Yes,
Ma'am.
ma'am.
Yes, ma'am.
Any questions here? So those four concepts of prevalence, cumulative incidence, incidence density, and I'll tell you hazard also. I'm just giving you a simple example to understand actually what we are trying to do when we use those terms. Now, supposing that you feel that the rate of flow in the tap is not constant and it's different in the two taps. So might be in the morning it could be more, and then it could get less. In the night it could again increase. So we really don't know. And might be the consumers want to know what is the time in which we are going to get more water. then you will have to place special sensors which are going to capture the amount of the flowing water for say every second, every minute or every hour. And you will have to then do a comparison of the amount of water which is flowing every hour for those 24 hours and see when is the time then that the water is flowing more in the given period of time in both these taps. That is hazard. For example, in the hazard, you may get that okay, the average overall water flow in the 24-hour period is the same. But in tap one, more water was flowing in the morning. And in the second tap, there was a higher flow at night. So what you have done, the entire period, you have split it up into small intervals of time, and in each interval of time, how much water is flowing, that is what you have seen. That is hazard. Are you understanding me here?
Yes,
Yes,
ma'am. Yes,
ma'am.
ma'am.
So you have to understand the differences between these four important concepts, which are measures of frequency. Now, usually when we read literature or when we are doing studies, we have a perception that okay, the best would be the hazard or the incident rate. But you have to understand that whatever your measure of frequency is and the study design you are going to use to make those estimates, everything actually depends upon the research question. Actually, if you are interested in studying the burden, prevalence is the best assessment. Actually, that could be the, for example, administrators or those who are implementing programs may want to know burden of the disease. So there is no harm in then studying the prevalence. If you want to study risk and risk factors for diseases, then you will have to look at risk and calculate incidence and incidence rates. And if you are interested in time to event and you feel that you want to see whether there is more survival or the outcome is occurring earlier, cure rate is far more earlier with a particular drug compared to another drug, then it is time to event and you will have to estimate hazard functions and hazard rates. So this is what I want to tell you all, that all of these measurements are okay. You should know what your research question is and what is the appropriate measure of frequency, and accordingly you should decide your study design and how you are going to collect your data. Then I'm going to actually look at tools of measurement, which usually comes before frequency measurement. But in tools, there is a very small thing which quickly we'll brush up through. We all know that there is ratio, there is proportion, and there is rate. Okay, so whenever you divide one value by the other, there is little confusion here. That's why I'm just touching upon these concepts. So whenever you divide one quantity by another, that is a ratio. And rates and proportions are special types of ratios. Proportion is where the numerator is included in the denominator. Everything in the numerator is a part of the denominator. And rate is where the numerator is a part of the denominator along with the time factor. So this we have already seen when we looked at measures of frequency. So nothing much here, but ratios are very broad. What I understand is that because there are many complicated forms of formula you will get. So whenever you feel that it is not a proportion or rates, it is, I think, safe to say that it is a ratio. Whenever there are numerators and denominators and you are dividing one by the other, it's a ratio. And all of these are examples of ratios which are there. It could be in maternal health or even in your standardized mortality ratio or in demography they are used. Proportion is where numerator is included in the denominator, so it's ratio of a part of the whole. And you can report a proportion either as a decimal fraction, a common fraction, or as a percentage. And the value here will vary or will range rather from 0 to 1, and if it's a percentage from 0 to 100%. So your cumulative, now why I'm telling you this is again just to reiterate that cumulative incidence is it's a proportion. So the number of new cases which are occurring in the specified population in a specified period of time by a multiplier. So this is the risk or the probability. It is an incidence, but in terms of the tools of measurement, it is a proportion. This is what you need to remember. And for the rate, it is a person time which has to be in the denominator. And the rate is actually telling you the speed at which the events are occurring. So normally, if you think if the speed is at which the event is occurring is more, if the rate is more, the risk is also likely to be more. And the rate, the values which rate can take is from 0 to infinity. So this is the difference between your cumulative incidence and incidence density. So cumulative incidence is a proportion, incidence density is a true rate. So the questions actually, when you are like jumbled up, whether it's a ratio, rate or proportion, you have to ask whether all the units in the numerator have come from the denominator. So if yes, it can be a proportion or a rate, and then whether it is percent time in the denominator. If yes, then it is a rate. Otherwise, it is a proportion. So in literature, many times the word rate is used very commonly, but you will see that these are not rates, right? So these are all either dependency ratio, of course, is a ratio, but all the other are either ratios or they are proportions. So this is something which you have to remember. You have any questions here?
Ma'am.
Yes.
Ma'am, so in this slide, these all are the tools of measurement, ma'am.
Yeah, tools of measurement is like when you are asked about tools of measurement, it's rate, ratio, proportion.
Okay.
So these are measures of either morbidity, mortality, and the tools of measurement are used,
To calculate these, ma'am.
yes, to calculate the frequencies.
Or like dependency ratio, case fatality rate, like that.
Yes, so you have either, it can be either a rate, ratio, or proportion.
Oh, okay.
So first, what I'm trying to say is, the word rate you will see everywhere, cropping up everywhere, but actually those are not rates. So case fatality rate actually is a proportion. Maternal mortality rate is a proportion. If you look very closely, infant mortality rate, it is calculated using life tables. It is a ratio. And annual new case detection rate is also a proportion. So rate is a word which is commonly used even when it is not a rate. Yes, Dr. Ida.
Ma'am, could you please tell me the difference between maternal mortality rate and maternal mortality ratio, ma'am? Because every time it's confusing.
Yeah, per 1,000 live
Hello.
births. Yeah, yes.
Mm.
So,
Sorry.
yes,
Uh,
Dr. Iram, I'm answering your question. So,
Yes, ma'am. Actually, ma'am, I was asking if I could get an example stating the difference between that previous slide that we are talking about cumulative incidence and incidence density.
you want an example?
Yes, ma'am. Means how do we differentiate? Like I understood the definition, but
Yeah.
as such, if we are explaining the students,
Yeah.
yes, ma'am, example.
What you have to look at is this, the denominator. If the denominator is percent time. Now, when will you use that denominator? You will use that denominator if you have a open population. That is, people are entering, exiting at different times. So you will want to take percent time in the denominator.
Yes,
Right?
ma'am.
Whenever you have percent time in the denominator and new cases in the numerator, that becomes incidence density.
Yes, ma'am.
And if you have total, if it's a closed population and you take all the people who were included in your study at baseline in the denominator, and out of those, how many new cases cropped up, that is cumulative incidence.
Yes, ma'am.
Okay.
Thank you, ma'am.
Yeah, and somebody was talking about maternal mortality ratio and rate. So maternal mortality rate, you have maternal mortality, which has a specific definition that is in the numerator. If live births are in the denominator, your numerator is not a part of denominator, so it is a ratio. But if there are women in the reproductive age group in the denominator, then your numerator is a part of the denominator. So actually it is a proportion. It is not a rate because you don't take person years in the or person months in the denominator.
Ma'am, could you explain this with an example, ma'am?
Which one?
this maternal mortality rate ratio you told me, like proportion, that numerator denominator thing, ma'am.
Yeah. So if you could get, if somebody could give me numbers, I will tell you. So if supposing the maternal mortality ratio is 70 per 1,000 live births, what does that mean? That means that there are 70 maternal deaths per 1,000 live births.
Okay.
Now, numerator, that is the mothers who have died, they are not actually part of the denominator, that is live births. Actually, if you look at the denominator, right? So they are two different numbers, and you are making some assumptions there. So it's only a ratio, like your sex ratio, right? Number of females per 1,000 males. So there is a different numerator, a different denominator. They are not part of each other. The numerator is not a part of the denominator per se. That becomes a ratio.
Okay.
Okay?
Okay.
Ma'am,
Like you have dependency ratio, where you have
ma'am,
different. Yes, yes, Shiva.
yes, ma'am. Ma'am, here case fatality rate, I can understand it's a misnomer, ma'am.
Yeah.
For maternal indicators and this child indicators, MMR and IMR, can we say that since we observe these people for 1 year, we talk about this 1 year time period, MMR for a particular year. So
Hmm.
can we say it as a rate, ma'am? Is it called rate because the time period is 1 year or something?
Yeah, those assumptions are made, but they are not pure rates. They are still
Okay.
proportions.
Okay. Okay.
Strict criteria for rate is you should have percentile. And you will see that in the national program, there are hardly any programs. All I could get a reference was in the National AIDS Control Program, where there are new cases per 1,000 person years is what is reported based on various models. So
Okay.
data is collected, and then based on models, those making some assumptions, those rates are, but in programmatic settings, pure rates are never calculated. So it's usually a proportion.
Proportion.
Yeah,
Okay. Thank you.
yeah.